As we already learned on Monday, there are key 3 heat transfer mechanisms. The first we learned is convection. And we know there is a simple equation to calculate the convective heat flux by the convection heat transfer coefficient times the temperature difference between the surface temperature and the temperature of the outer fluid. Then the second one mechanism is radiation. The thermal energy emitted by a matter and through the electromagnetic waves, and in a very radiative heat flux is captured by something called Stephan-Boltzmann law. The emissivity of the matter times the sigma, the Stephan-Boltzmann constant. This is 5.67 times 10 to the minus 8 power times the temperature difference between the surface temperature but to the fourth order, then minus that of the surrounding. Some is the surrounding temperature is always the same as that of the outer fluid. They are not necessary. They are not the same concept. So sometimes they can equal to each other. The T infinity, we use this to represent the fluid of a moving outer flow. And the T surrounding is, let's imagine a surface being completely enclosed by a larger, for example, we sit in the classroom or the walls of a room. So they are not necessarily the same. And the third one we learned is conduction, and is also called the Fourier's law. In one dimension, it captures by the temperature gradient along the heat transfer, the direction of heat flow. And if we have a temperature profile here, temperature profile is the temperature value for each point inside. Let's assume X should be this one. Let's assume heat flows in X direction only, and the gradient of the temperature with respect to X is the slope of the temperature profile. We assume it is a linear relationship, so which means the slope is a constant, and K is termed as the thermal conductivity. And in the unit of watt per meter per Kelvin, this is the property of the material itself to represent how efficiently it can conduct thermal energy through the medium. And why we put a minus sign here? That's due to the fact that the heat is always transferred in the opposite direction of the positive temperature gradient. As we see here in the profile, it has a positive temperature gradient, but heat is always transferred from the higher value to the lower ones. So that's the opposite direction of the temperature gradient. Then we should put a minus sign here.